this section, we are going to be studying what we call the polar coordinate system. The polar coordinate system has points, just like our regular coordinate plane has points. Our polar coordinates, however, are found by r theta as opposed to xy. R theta, r is the distance away from the pole, which is like our origin. So we could go to the right or to the left. That's like our x value that we're used to, moving right or left to get off of it. And then our y value is actually going to be an angle measurement. This could be an angle given to you in radians or degrees. And that tells us how far to move off of. This x-axis that we think of is actually called the polar axis in polar mode. So we could move a certain distance to the right or left and then move our angle measurement off of that polar axis. All right, we're going to do an example together here. I've got two different points here. One is the point 2, 5 pi over 3. So our r value is 2. So to start with, I am moving, here's our first unit, here's our second unit. So I'm moving out 2. And then I want to go 5 pi over 3, which I know is an angle, it's a 60-degree angle in the fourth quadrant. So looks like 30, 45, here's like our 60 degree. We're just going to kind of estimate that here. So this would be the point 2, 5 pi over 3. Now if I really wanted to draw what that looks like, I could give myself like a starting point. I've wrapped around 5 pi over 3. This is like our ending. So here's the 5 pi over 3, and the fact that it's 2 out is why we're here. We can also have negative r values. So the difference here is we will go to the left, and we're going out 3. Now I want to go pi over 4. I'm always measuring positive angles counterclockwise. So I'm going to start here this time, but go counterclockwise. And right here should be my pi over 4 mark. So this is the point negative 3 and pi over 4. You don't always have to have this circular axis in order to graph polar points. I've seen people simply do it on a typical coordinate plane. It's just a little more estimated. So if I wanted those same points on a typical coordinate plane, I would go over 2, and then know I'm going about 60 degrees. And I just sort of estimate what that 2 would look like over here in quadrant 4. Negative 3 and pi over 4, 1, 2, 3, and then go about my 45 degrees. So again, it doesn't have to look perfect. I've seen people do it just on a typical, with x and y axes, and they just sort of estimate where that point is. So it does not have to be with this specific of a polar coordinate plane. You can also have, I didn't give you an example, but we could have a negative angle measurement. So let's take this one. Say we had negative 3, negative pi over 4. The only difference with negative angles is we'll go clockwise. So instead of going the typical counterclockwise, I would go clockwise and have my negative 3 and my pi over 4. One last connection I'd like us to make here with plotting points is seeing number 1, if one's given to you, could you actually name it? So let's see if you can come up with the ordered pair for this. If you want to pause for a second and come up with it, I'm going to go ahead and give the answer here. This is actually, it looks like it's out on the third one, so we're out 3. So if I went this way, 3, and then came wrapping around, this is a 45-degree angle in quadrant 2, which is 3 pi over 4. You could also give 135 degrees here, it just depends. What you may have noticed is we also could have gone a negative direction. So there's other points that give the same coordinate. So we could have also gone negative 3. Now, if we went negative 3, we could go backwards to get this point, or we could have wrapped around all the way to here. Now, if we did that, negative 3, and then wrapped all the way around, that would have taken us 7 pi over 4. We could have gone negative 3, negative pi over 4. Something else you might have thought of here, kind of similar to our coterminal angles, is we could have done positive 3, and we could have gone around and then back to 3 pi over 4. So it's almost like we could have taken 3 pi over 4 and added 2 pi to that, and that would have given us another ordered pair. What I want you to see is that we could get infinitely many ordered pairs that go to the same point. And part of your problem set that you're working on is wanting you to come up with a rule to show you how to always get all the different coordinates that are possible. So you should be thinking of a rule where the r stays the same as what was given to you, and then how do you come up with that angle? And then there should be another rule where you could actually go the opposite direction, and how does the angle calculate it that way? So we'll work on that in class. That's kind of one of the harder things to do, is to come up with that rule.